Morning everyone, I am Rupesh H of GM University Davangere, first sem, pursuing my BTech in CSE. So today the subject of my presentation is deep learning and LLM. So over here my presentation topic is comparison of CNN and LSTM models for sentiment classification on Amazon product reviews. The main goal of my project is to analyze customer feedback from Amazon product reviews dataset and classify them either as positive or negative. So I'm doing this project alone. So here is my name and USN, Rupesh H. Chaudhary and the unit USN. Sentiment analysis using deep learning. Sentiment analysis helps companies understand how customers feel about their products. Instead of manually reading thousands of reviews, we can use AI models to automatically predict the sentiment. In this project, I have used basically two types of deep learning models. One is the CNN and one is the LSTM, which is the long short term memory, and compared performance for the text classification, dataset, and pre-processing. For pre-processing, I used, in essence, for this project, I have used Amazon product reviews dataset. The dataset contains thousands of customer reviews along with star ratings. I converted the star ratings into binary classes. Reviews with 4 or 5 stars were labeled as positive, and reviews with 1 or 2 stars are labeled as negative. Before training, I pre-processed the text by cleaning it, removing punctuation, converting all text to lowercase, and removing stop words. Then I tokenized the words into numerical IDs, padded each review to 200 words, and finally converted them into 128-dimensional word embedding. Basically, the data set was split into three parts. One is the training, validation, and testing data testing sets, which is 80, 10, and 10% respectively. In the sense, training is 80%, validation is 10, and training sets is 10. So the CNN. The first model I implemented was a CNN. Although CNNs are commonly used in image processing, they also work well for text because they can identify important local word patterns. Like, for example, if I say very good or not worth it, they strongly indicate my sentiment. The CNN architecture used over here includes embedding layer, conv 1D layer with 128 filters in it, following by global max pooling and dense layer with a sigmoid activation. The CNN learns short-term dependencies efficiently and trains compared to the faster to LSTM model. So this is about the CNN. This is LSTM. So the second model over here which I have implemented is LSTM, which is a long short-term memory or LSTM as I said. LSTMs are a type of recurrent neural networks that can remember information over long sequences. Unlike the CNNs that look at short phrases, LSTM understand full context of a sentence. For example, they can catch the meaning difference between not bad at all and bad. So basically, these two are very different. One is saying that it is not bad. One is saying it is bad, just in a word. That's it. The LSTM architecture I have used over here has the embedding layer followed by an LSTM layer with 128 units and a dropout layer to prevent overfitting, and finally a dense layer with a sigmoid output. The LSTM takes a bit longer to train, but they generally give more accurate results for sequential data. So this is the implementation details. I've used Python over here, and for platform I have used VS Code. The CNN and LSTM were trained on exactly the same preprocessed data so that the results could be compared accurately. hyperparameter tuning and optimization. To improve performance, I performed hyperparameter tuning on both models. I experimented it with learning rate, dropout rate, and number of filters or LSTM units and batch size. Using the learning rate of just 0.001, dropout of zero point 0.3, and 128 units gave the best results to me. After tuning, CNN accuracy improves to around 87%, and LSTM's accuracy improves nearly to 90%. Techniques like early stopping, dropout layers, and learning rate scheduling help reduce overfitting and improve overall model stability. So the conclusion part, to conclude, both CNN and LSTM models performed very well on Amazon review dataset. The CNN was faster and effective for short answers, while LSTM model provided better accuracy by understanding the sentence context. This shows that the choice of model depends on the type of data and the type of application. The future scope over here, I would like to try hybrid models combining both CNN and LSTM layers together, or even transformer-based models like BERT, which are currently state of the art in natural language processing. So basically, this is my presentation. I'll be taking you through the code which have run over here. So basically, this is the code. I have used Python code over here for comparison of CNN and LSTM. So basically, I have made the code in such a way that after, in the sense, training the model, I'll get the images of the results over here itself. In the left side, you can see CNN accuracy curve, CNN confusion matrix, CNN loss curve, CNN versus LSTM accuracy comparison, etc. So basically over here, I have run the code once already, but once more I will right now. It takes a bit time. The data set has 5,000 lines in it. So over here you can see the data set. I mean 5 lakh lines over here. Wait a second, it's getting load. Yeah, over here like this. This is the data set, and it is a very large data set. So I've reduced the reading till 35,000. So it will take only 35,000 inputs. I'll run it now. This is the reviews CSV. I've converted it into CSV file and placed over here. So I've used Matplotlib for visualization over here. So APOC 1, which is the first iteration, APOC 2, which is the second one for CNN. In both, it takes only 2 iterations. I've limited it, or else it will take around half an hour to train the models. So for presentation purpose, I have reduced it to 35,000. See, once it is done, we'll get the data over here itself, which is the precision. It is 0.78, which includes to 0.86, recall 0.13 to 99, F1 score 0.23 to 92, and support to 82 to 1546. So accuracy, macro accuracy, macro weight, etc. over here on the LSTM classification report is also visible. So basically, all the result is saved over here. So I'll go through all the results right now. So basically, first one is the CNN. So I'll finish off CNN and then take you to LSTM. The CNN accuracy curve. So basically, this is the CNN accuracy curve. So when it was getting trained, you can see the curve over here, and when it got trained, in the sense at the last, at the validation point, it is increased. The accuracy has increased over here. The CNN confusion matrix, you can see over here. This is the confusion matrix, which has an accuracy of 0.86. Over here, you can see the loss curve. First, it was a bit high, but after the validation, it doesn't have that much. So next is the LSTM accuracy curve. The same results over here too. The confusion matrix, it has a bit more. The loss curve has also decreased, and this is the final comparison, CNN versus LSTM accuracy comparison over here. So basically, this is the accuracy. In the sense, 0.86 is of CNN and 0.89 around 90 is of the LSTM. So thank you everyone for taking time and listening to my presentation. And I wind up over here.